Okay, number 11 is the pathway from hell. Okay, this is probably the worst pathway, and probably why there are no papers that have to do with mTOR. Who's taking immunology? Did you guys talk about mTOR once?
Not really. Other than the fact that it's related to the IL-2.
Oh, is it right?
IL-2
Okay. I mean, I don't blame Dr. Dillon for not talking about mTOR. It is awful. This pathway is awful. So, okay, here we go. So here's substrate number 11. Okay, get ready, hang on to your hats. But you've learned all semester how to handle difficult pathways. So here's your final exam. Okay. So AKT activates the mTOR pathway. There's actually two mTOR complexes, and I can't tell you which one we're using because I always forget the difference. But I mean, I know the difference, but I just can't remember which one's mTOR 1 and which one's mTOR 2. So mTOR equal is the mammalian target of rapamycin. Okay, so I think it came up because so maybe in immunology, cells treated with rapamycin. Oh, that is a good anti-cancer drug, by the way. But they also probably are, is that an anti-inflammatory treatment too, rapamycin? I don't know. I don't know from an immunological standpoint. Okay, so here is how AKT activates the mTOR pathway, and then we're going to look at what does the mTOR pathway do. Okay, so the substrate for AKT is not mTOR. Okay, it just leads to mTOR activation. All right. So here are the actual substrates. Two proteins who form a heterodimer, OTSC1 and 2. This is 1. And this will be OTSC2. These make up an active gap, okay, a GTPase activating protein. Okay, but when AKT11 phosphorylates TSC1 and TSC2, now this is an inactive gap. Okay, so far so good. Okay, so AKT maintains an active gap complex. Okay, the G protein is red. Notice that, like lots of the G proteins begin with R. Rab in there. Okay. Okay, and as you know, anything that has DP, any G protein with the GDP on it is inactive, and anything with the GTP on it is active. Okay, so, okay, AKT then leads to the inactivation of Reb. That make sense? Okay, it leads to the inactivation of Reb. Okay, here's what Reb does. Finally, we're at mTOR. Okay, mTOR is a protein kinase, but when it's sitting here all by itself, it's inactive. So it's an inactive protein kinase. Oh, yeah. Okay, we're doing all right, we're doing all right, we're doing great. Okay, and it will bind to, mTOR will bind to the protein Raptor, and it'll phosphorylate Raptor, and this is active. Okay, so there's another mTOR complex, but it's not Raptor that's bound to mTOR, it's something else, and I can't remember what it is and whether this is mTORC1, but this complex is called mTORC because it's in a complex, and it's either mTORC1 or it's mTORC2. And I don't have it in my notes. Okay, so now we've just, so here's what we've done. So AKT inactivates the gap. So Reb remains active, and that leads to the activation of mTORC, or the activation of mTOR. Okay, does that make sense so far? Oh yeah, I know. It's like you're inhibiting the inhibitor, okay? So AKT inhibits the inhibitor. So AKT knock up gap activity. Reb has to remain active, okay? And that leads to the activation of mTOR. Okay, you got that? Yes, Rufa.
So does Reb add Raptor to mTOR, or how does that happen?
So the Reb allows the complex to form. Okay, so Reb is allowing the mTOR complex to form, and this is the active protein kinase, this is the inactive protein kinase. Okay? And really, AKT, indirectly locks Reb into the active configuration. Because we're not going to allow the GTP to be hydrolyzed on Reb. So you get a lot of mTOR activity. Okay, so we're going to look at 3 consequences. Oh, and then I'm going to do, if we have time, I want to do one more icky thing. Okay, so as a protein kinase, there are several substrates.
Dr. Senator, can you explain that one more time?
Oh, okay, I can, okay? Because it's so mixed up. Okay. So when AKT phosphorylates this gap, it inactivates the gap. Okay? So what that means is that Reb is stuck in its active configuration because you've just gotten rid of this.
Makes sense.
Got it? So this is the form of TFC now. This is not the form. Okay. So this is how it would look on paper. AKT blocks PSZ1, PSZ2, which blocks Reb. Okay, so you're inhibiting the inhibitor. Okay, so we have Reb that now is stuck in the active form. Does that make sense? You got to there? Okay. And what that means is that there's going to be a lot of mTOR activation. don't you think this is like the most screwy pathway we've ever seen? The problem is mTOR is a central regulator of so many cell activities. Okay, so you got that? Everybody okay with getting AKT leading to the activation of mTOR? Good, because mTOR is going to activate a protein kinase.
So is mTOR still a protein kinase?
It is a protein kinase, and it's going to phosphorylate another kinase, S6 kinase. I'm leaving one out here, so I not get to all of them. Okay, so through phosphorylation, okay, S6 can knock out a lot of things. Through, when it's active, it's going to phosphorylate a whole bunch of things and inactivate those things. For example, just in case AKT happened to miss GSK, well, F6 kinase can also hit JSK and knock it out. Okay? We got that one. Just in case AKT missed BAD, BAD can get phosphorylated and knocked out. Okay, so I think if you remember, BAD is the phosphate group can be bound by 14.3. Okay, this can lead to I can't say this. EIF4B. Okay, now those of you with molecular genetics, we've never covered an EIF4B. We've covered EIF4E and A and G, never covered EIF4B. Okay. It is, this guy is an inactivator of EIF4, okay, which is required for protein synthesis initiation. I can cover it in, I probably cover it in molecular genetics, but it's not worth it in this class, okay? So if we knock out this inhibitor of protein synthesis initiation, what's going to happen to the rate of protein synthesis when mTOR is active? It's going to increase. We're going to see more protein, no, sorry, Ryan. We're going to see more protein synthesis activity. We're knocking out the inhibitor. Okay, so we're inhibiting the inhibitor of protein synthesis. So all you have to see, when you see a double negative, okay, just like in the English language, a double negative means it really is positive. So really indirectly, we're going to see an increase in protein synthesis, okay? Because we're inhibiting the inhibitor. So there's another one, there's actually another one that will, I'm just going to give you a couple of steps and we'll go through this. Okay, there are a couple of other steps. SK6 kinase activity, S6K kinase activity will also lead to increased activity of the initiating protein synthesis initiating factor EIF2. So you're going to see a lot of protein synthesis activity when mTOR is active. Okay, enhanced protein synthesis activity. Okay. Okay, that was all I wanted, I think that's enough. Okay, then one more thing, however, have we done autophagy? Okay, this is your final test question. Okay, mTOR, when it's active, blocks autophagy. Okay. So if a cell happens to be hungry, okay, not enough amino acids in the nutrients, okay, some could be somebody who is not consuming enough. It could be my cells downstairs that I feed so infrequently. There are just not enough amino acids coming in, not enough other kinds of nutrients. Would you want mTOR to be active or inactive? You'd want it to be, would you want a lot of protein synthesis activity going on if you are not getting enough amino acids in the medium? No, so you want to inhibit, right? You want to inhibit mTOR activity. And you can't. There is a competing protein kinase. Ready for this one? Okay, and it has to do, so AKT phosphorylates TSC1 and 2 and really inactivates it. There's another protein kinase that has the opposite effect when it is active. Gap. Okay? A different set of phosphate groups creates an active gap. And the enzyme is AMP dependent protein kinase. So what activates AMP dependent protein kinase? AMP, where does it come from? So if you are using your energy sources, okay, you're kind of running out of your capacity to produce ATP in the cell, the concentration of AMP goes up. Okay, so AMP buildup in the cell is really a sign of starving. Okay, so high AMP is really kind of a starvation signal because it's not being recycled into ATP by the FOF1 ATPase. You call it ATP synthase, I think in bio-111. Okay. Okay, so AMP kinase also puts on some phosphates on TSC1 and TSC2, but that enhances the gap activity. Okay, so that enhances this. Okay, we've just inactivated Reb, so we fail to activate TOR. Yeah, and Sylvan.
Does AMPK phosphorylate as TS1 and TS2 on the same residue?
No, it has to be a different one because these are inhibitory phosphates. These are activating phosphates. So we see increased inactivation of Reb. What's going to happen to the amount of autophagy? It's going to increase, and so what do you suppose the consequence of increased autophagy will be? So when in autophagy, organelles and proteins are broken down. This is the cell's attempt to what? This is the cell's attempt to recycle proteins and get more amino acids. Okay? So proteins that we could get by without, organelles can be broken down. The consequence is it makes more amino acids so that this process can continue. Okay? So that's exactly, so that's what's going on in energy metabolism, is that increased autophagy is done to provide nutrients that are missing from the medium. So you start eating yourself, and there's some health benefits to that, because a lot of stuff that you could be consuming or be digesting by autophagy would be stuff that's not that great, that's been around in your cell for a little while. Okay. And actually, that's what is now linked to why people who just under-consume calories live longer than people who eat excess calories. Is that the increased autophagy is getting rid of a lot of the things in the cell that aren't needed, down organelles and old protein.
So did you say high levels of AMP or starvation signals?
Yeah, yeah. Because the AMP came from the ATP, but now we've run out of the ability to regenerate ATP. Okay, so I will, before I go home today, I will see if there are any more assignments uploaded, and on the four of you who submitted, I will get yours ready today and tonight. And get it back to you.
Is the study guide updated?
Is there a study? Oh, wow, that'll give me something to do. I'm, well, I'll still upload it first, that doesn't take long. Never. So my computer died twice during Thanksgiving break, and it means that the first letter I wrote so I rewrote it last night.